Secure your Elixir apps with Paraxial IO. From code analysis and bot defense to dependency checks, they've got you covered. Elixir first design with GitHub integration. Elevate your security at Paraxial.io. What is up, guys? I don't know if chat is going to work. What's going on? I guess we will find out. Today we are continuing the anti-patterns little guide. Let's see, earlier, is today Thursday? So Tuesday we did the code-related design anti-patterns, and today we're doing design-related anti-patterns. So I think it'll be a lot of fun. And why don't we just jump right in? And what's up, everyone? For the viewers listening, I'm gonna just type what's up. I want to just see if chat is working. It's always, please share a beginner's guide for those coming from other ecosystems. Go to Node. I mean, my Elixir Basics playlist would be a pretty good place to start for that. And then the Real Deal API is good. And then I would do my gist clone, the live view, and Elixir Getting Started guide. I did a whole series from the documentation there. And that's a great playlist. I think it's like 24 live stream videos. So those are all great spots. So yeah, lots of stuff for people just getting started. And let me just pull up Safari. I think I have Safari open in another window. Let's go to elixirlang.org and pull up the docs, or not the docs, the guides. And let me share my screen here. And then on the left side here, we're going to anti-patterns, and then we're starting on design-related patterns. And then I'll make this full screen. And hopefully this is big enough for everyone to read. Same as last time, I'm probably going to do less like coding. I think we'll just be reading and going over the examples, because this stuff is more, I think it's better conversational stuff, and walking through the examples and just discussing it is a great way to do it. So let's get started. These are long. I have to like get mentally prepared to do this much reading out loud. All right, so design-related anti-patterns. This document outlines potential anti-patterns related to your modules, functions, and the role they play within codebase, within a codebase. Alternative return types, okay? So the first anti-pattern. So the problem, this anti-pattern refers to functions that receive options, typically as a keyword list parameter, that drastically change the return type. Because options are optional and sometimes set dynamically, if they also change the return type, it may be hard to understand what the function actually returns. I think, do people really do this? Because I like, maybe people do, but I would definitely not write code that would return two different code types. Let's go through their example and see what's actually happening here. All right, so we have a module called alternative integer, and we have a function called parse. And let's see, it takes a string and then it takes a list of options, and by default it is an empty list. And then we have a guard, and we're making sure the options being passed in is a list. That makes sense. All right, so then if keyword.get options, they're looking for a key value called discard rest. And let's see, if that is false. So if that is false, then we are taking the integer and we're parsing the string and returning an integer. All right, and then if parse fails, we return an atom error. And then I'm guessing if discard rest is true, it looks like we're just parsing, we're doing integer.parse here. All right, so let's see. Okay, so now if we go down in their little IEX example, they're passing in a string 13. And by default, discard rest is false. So let's see here. We're doing parse 13 as a string, and it's returning a tuple. with 13 and then an empty string. All right, so then alternative integer, if we pass in the options discard rest, one thing to know here, if you're passing in one option, you don't have to include the square brackets for your options. It will automatically be considered the first item of a list. And so it is returning the tuple again. And then when discard rest is true, instead of returning a tuple, it is returning an integer. So I don't know, if you ask me, this makes a lot of sense. You wouldn't want to do this. This would be very confusing because your return type is dynamically changing depending on your options. So let's see, refactoring. To refactor this anti-pattern as shown next, add a specific function for each return type. For example, parse discard rest arity1, no longer delegating this to the options passed in. That makes sense. So if one of your return types is returning your tuple, have a whole separate function for it. And if one is returning integers, have a separate function for it. Like, this just makes sense to me. This is what you would want to do. So if you're writing code that returns different code types, don't do that. That's silly. So now when they do this, when we're just calling parse, it returns the tuple. And then when we're saying parse discard the rest, it's just returning an integer. So they just broke it up into two functions. And yeah, the other way just has bad code smell. Don't do that. And let's see. Name war Verge Ben. Yeah, see, I agree, dude. I don't like different return types either. All right, and then moving on. Boolean obsession. Problem. This anti-pattern happens when Booleans are used instead of atoms to encode information. The usage of Booleans themselves is not an anti-pattern, but whenever multiple Booleans are used with overlapping states, replacing the Booleans by atoms or composite data types such as tuples may lead to clearer code. This is a special case of primitive obsession specific to Boolean values. So let's see the example here. An example of this anti-pattern is a function that receives two or more options, such as editor true and admin true. To configure its behavior in overlapping ways, the code below, the editor option has no effect if admin is set, meaning that admin option has higher priority than editor, and they ultimately are related. Okay, so let's see here. We are passing in options, and let's see, it's looking, okay, so right now the options would take a key value list, right? And one key would be Adam with a Boolean set to true or false, admin, and the other key would be editor, and that would be set true or false. All right, so this makes sense too, because, well, I think like anyone writing this code would be like, well, yeah, an admin probably has more access and rights than an editor, so it doesn't matter if the admin supersedes editor. But I get what they're saying. Like you're overusing Booleans when it isn't really needed. You probably could just have a key value. I bet. Oh yeah, down below. So I like their refactor. They're just going to have a key value in options called role, right? And then you would pass in admin, editor, or default as values. And then it can only be one of these things. So your role is an admin, editor, or default, not a bunch of Booleans. So that makes sense. That just looks cleaner. It makes a lot more sense. But I could see how this could get into code because it makes sense logically if you're not thinking about it and like overusing things. Sometimes the simpler solution is the way to go, right? All right, so this anti-pattern may also happen in our own data structures. For example, we may define a user struct with two Boolean fields, editor and admin, while a single field name role may be preferred. That makes sense too. So like whether it's role or user type or all of these, you would have a specific setting for them. You wouldn't have added fields to your struct, because that could just be messy, because then every time you add a role, you have to create a new field on your struct instead of just adding a new value. All right, so finally, it is worth noting that using atoms may be preferred even when we have a single Boolean argument option. For example, consider an invoice, which may be set to approved or unapproved. One option is to provide a function that expects a Boolean. All right, so we have our invoice, and then we have an approved field in our invoice struct, right? And we're setting it to true. So I guess like in this case, you would set it to true or false. And so one thing that if you do it this way, I don't know, like I get they're talking about readability here because down below instead they have status and you'd have approved or unapproved atoms. But if I were to use a Boolean in my code, I don't think I would just have like approved, right? I would want it to be clear that it's a Boolean. So I would do like is approved, and then that could be true or false. But I do like the route of using an atom as the status much more than a Boolean. Now remember, Booleans are internally represented as atoms. Therefore, there is no performance penalty in one approach over the other. So that's also good to remember. All right, now exceptions for control flow. Problem. This anti-pattern refers to code that uses exceptions for control flow. Exception handling itself does not represent an anti-pattern, but developers must prefer to use case and pattern matching to change the flow of their code. Instead of try rescue, in turn, library authors should provide developers with APIs to handle errors without relying on exception handling. When developers have no freedom to decide if an error is exceptional or not, this is considered an anti-pattern. All right, so an example of this anti-pattern is shown below, is using a try rescue to deal with file operations. All right, so we have our function here called print file. We're passing in a file, and then inside of our try do block, we're attempting to read the file, and if this throws an error, we're returning the error and just displaying the message here, right? And let's see. So refactoring, let's see the example here. So now if we call print file, valid file, it reads this is a file, valid file, great, and returns the atom okay. Invalid file, could not read file, no such file or directory, okay? So I think I see, okay, and then they're refactoring the same function. Instead of doing the try rescue here, relying on the error, right? They are going to not use the bang operator. So whenever you see this, that's the bang operator, it will always raise an exception. And in some cases though, like you might not want that, right? You might want to raise it yourself. And so right here, now they're using it without the bang operator, the exclamation point, right? And they're handling the returned tuple. So they're pattern matching to okay and error. And then you can handle however you want to handle that error. So this refactor, so to refactor this anti-pattern as shown, use the read arity1, which returns tuples instead of raising when a file cannot be read. And yeah, this approach is usually better because you want to handle the errors the way you want your platform to, right? So it makes sense. All right, this is only possible because the file module provides APIs for reading files with tuples as results. So file.readArity1, as well as a version that raises an exception with the bang operator. So the bang is effectively part of Elixir's naming conventions. Library authors are encouraged to follow the same practices. So in practice, the bang variant is implemented on top of the non-raising version of code. So for example, the read with the bang operator is implemented as the following. So let's see. Yeah, so they're saying if we're the library author here, this would be our read function. And then we're raising the error instead of just returning an error. And yeah, that's pretty common practice. So that's why you'll always see the bang operator in your like context file and whenever you're dealing with other APIs. So a common practice followed by the community is to make the non-raising version return the OK Atom results or the error with the exception message. So for example, an HTTP client may return OK with the HTTP response on success cases and an error with the HTTP error response for failures. Where the HTTP error is implemented as an exception, this makes it convenient for anyone to raise an exception by simply calling the kernel.raiseArity1 function. Additional remarks. This anti-pattern is of special importance to library authors and whenever writing functions that will be invoked by other developers and third-party code. Nevertheless, there are still scenarios where developers can afford to raise exceptions directly. For example, invalid arguments. It is expected that functions will raise for invalid arguments as those are structural error and not semantic errors. Semantic errors. For example, file.read123 will always raise because 123 is never a valid file name. During tests, scripts, etc., those are common scenarios where you want your code to fail as soon as possible in case of errors. Using the bang functions such as file.read, bang operator arity1 allows you to do so quickly and with clear error messages. Okay, yep, that makes sense. Some frameworks, such as Phoenix, allow developers to raise exceptions in their code and uses a protocol to convert these exceptions into semantic HTTP responses. This anti-pattern was formerly known as using exceptions for control flow. Let's check that out. Elixir smell. Lucas, yeah, this is great stuff. El Delfo sent this to me on X, and then I had the pleasure of discovering Lucas. So definitely check this out, the catalog of Elixir specific code smells. It is good stuff. All right. Now, primitive obsession. So the problem, this anti-pattern happens when Elixir basic types, for example, integer, float, and string, are excessively used to carry structured information rather than creating specific composite data types, for example, tuples, maps, and structs that can better represent a domain. Example. An example of this anti-pattern is the use of a single string to represent an address. An address is a more complex structure than a simple basic, aka primitive value. So we have a module here with two functions, and the first function is extract postal code from address, and then we're just checking to see if the address is binary, and then we're running code here, right? And then we have another function called fill in country passed in the address, and we're just checking if the address is a binary, and then we're doing code. So I believe in this example, they're saying that address is just a giant string. So we'd be parsing the string, looking for a postal code that might not exist, which obviously could just lead to very buggy and unstable code, right? And then same with fill in missing country. You'd have to parse the string and even figure out if the country is included. And then you're also forcing people to probably stick to a very specific pattern for the string, so you know where you're finding the postal code, the country, all these things. So yeah, this is messy. So while you may receive the address as a string from a database, web request, or a third party, if you find yourself frequently manipulating or extracting information from the string, it is a good indicator you should convert the address into structured data. Yes, I agree. Another example of this anti-pattern is using floating numbers to model money and currency, when richer data structures should be preferred. I've done some podcast episodes on currency, and yes, you want to use libraries that are used for currency math and things like that. And if you want to stay away from libraries, you want to consider using integers or strings, because floats are always rounded, they're not exact. I don't remember how many decimals they go, but there is always going to be rounding errors if you're doing currency math with floats or doubles and things like that. So you don't ever want to do that. You'd want everything to be like an integer and then apply the decimal after you do your math. But it's easier, and like in this case, money is a great library. I would highly suggest using it if you're doing currency math. So refactoring. Possible solutions for this anti-pattern is to use maps or structs to model our address. The example below creates an address struct, better representing this domain through a composite type. Additionally, we introduce a parse arity1 function that converts the string into an address, which will simplify the logic of remaining functions. With this modification, we can extract each field of this composite type individually when needed. All right, so we're creating an address struct with a street, city, state, postal code, and country. And then we have one parse function. So we're still assuming address is given to us as a string, right? But then we're parsing it and returning an address struct, which is much better, right? Now our extract postal code takes an address, and we can just grab the postal code from our address struct. So address.postal code instead of parsing in every single function. And then same in fill in country. We can check to see if our country is nil or not. If it is, then we know we have to fill in the country, right? Makes sense to me. Like, you only want to parse in one spot too, because if you're constantly parsing and pulling apart strings, more buggy code and, just more opportunity for errors to enter your code base and data, because you could corrupt your whole database with a bad parse function. Unrelated multi-clause function. Problem: using multi-clause functions is a powerful Elixir feature. However, some developers may abuse this feature to group unrelated functionality, which is an anti-pattern. All right, I feel like this is going to be another good one, kind of like I forget the one above. Oh yeah, the different return types. All right, so a frequent example of this usage of multi-clause functions occurs when developers mix unrelated business logic into the same function definition in a way that the behavior of each clause becomes completely distinct from the others. Such functions often have too broad of specifications, making it difficult for other developers to understand and maintain them. Some developers may use documentation mechanisms such as @doc annotations to compensate for poor code readability. However, the documentation itself may end up full of conditionals to describe how the function behaves for each different argument combination. This is a good indicator that the clauses are ultimately unrelated. All right, so let's see what's going on here. All right, we have some documentation here. This updates a struct. All right. If given a product, it will. If given an animal, it will. All right. I mean, this already tells you. So you have an update function, you're pattern matching for a product struct and an animal struct. They're obviously very different things. They should probably be in different modules. And if there is a reason that they're in the same module, they should probably have different function names because they're going to return different things. One's going to return an updated animal struct and one's going to return an updated product struct. So yeah, if updating an animal is completely different from updating a product and requires a different set of rules, it may be worth splitting those over different functions or even different modules. I would probably lean towards different modules in this case. Refactoring. As shown below, a possible solution to this anti-pattern is to break the business rules that are mixed up in a single unrelated multi-clause function in simple functions. Each function can have a specific name and @doc attribute. So describing its behavior and parameters received. While this refactoring sounds simple, it can impact the function's callers, so be careful. And what they're saying is, so yeah, they broke it up into two separate functions, which it should be, right? And then you can have documentation for each one. So this updates a product, this updates an animal. But now that they changed the function's name, update product arity1, update animal arity1, you have the potential of breaking your code all over the place because you changed the function name. But don't write code like this in the first place. But if you do, rewrite it to be more clear. It's like the second you have functions that are doing multiple things, it's a good sign that you got to break things up, because one function should do one thing, right? These functions may be implemented with multiple clauses as long as the clauses group related functionality. For example, update product could be in practice implemented as follows. So let's see, we have an update product and we're pattern matching. As long as count is 0, we're doing this. And then we're doing update product. And then we have a guard when the material is metal or glass. Okay. And then we have another one when material is not metal or glass. So yeah, this makes sense to have a multi-clause functions here, because we're updating a product in all of these things, correct? And we're just adding some guards and things. And this is how you should use guards and pattern matching. And it's all related to a product. So no matter what, you're getting a product struct back, or at least updating a product struct. All right. You can see this pattern in practice within Elixir. The plus arity2 operator can add an integer. It can add integers and floats together, but not strings, which instead use the concatenation operator. In this sense, it is reasonable to handle integers and floats in the same operation, but strings are unrelated enough to deserve their own function. You will also find examples in Elixir of functions that work with any struct, which would seemingly be an occurrence of this anti-pattern, such as struct arity2. So let's see. URI, so we have a struct and we're passing in the URI parse foobar. Hi, would that make sense to get rid of the second guard? Do we want for extra readability? Let's see. I guess you're talking about the one material is not metal or glass. So, yeah, I guess it would depend. It would depend on what you're doing, right? If you have like 50 other materials and you only treat metal and glass different, it would probably be good to have the when it is not metal or glass as the fall through. You wouldn't necessarily, I feel like a guard, it's a good safety there. You might not necessarily need the guard there. You could, so as long as the material isn't metal or glass, you could update the product, right? So I guess it would just depend on use cases for sure, but definitely a good question. All right, now we got to figure out what's going on here. So we have struct. I'm going to cheat and look at the documentation to remind myself. All right, so we pass in a struct. All right. And what does it return to us? It returns a user as a struct. User named John. Dun, dun, dun. Struct, it takes a user and a map name. Okay, so back to this. We're passing in a struct. So URI parse, we're parsing foobar, and then we're passing in path. And path is, so obviously it's going to create a URI struct, right? And then it's going to set the path equal to the value that we're updating it to. All right, so the difference here is that struct arity2 function behaves precisely the same for any struct given. Therefore, there is no question of how the function handles different inputs. If the behavior is clear and consistent for all inputs when the anti-pattern, then the anti-pattern does not take place. Okay, I guess, yes, this makes sense. So we're taking a struct, oops, taking a struct of URI. Yeah, okay. So using application configuration for libraries. Problem: the application environment can be used to parameterize global values that can be used in an Elixir system. This mechanism can be very useful and therefore is not considered an anti-pattern by itself. However, library authors should avoid using the application environment to configure their library. The reason is exactly that the application environment is a global state. So there can only be a single value for each key in the environment for an application. This makes it impossible for multiple applications, depending on the same library, to configure the same aspect of the library in different ways. Okay, so an example is the dash splitter module. Represents a library that configures the behavior of its functions through the global application environment. These configurations are concentrated in the config.exs file shown below. All right, so we have our config and we're setting parts to 3, our dash splitter. Okay, so we're implementing this from our config file. One of the functions implemented by dash splitter is the split arity1. This function aims to separate a string received via a parameter into a certain number of parts. I'm sorry if you guys hear that noise. I feel like it's hitting my mic at the worst frequency right now. It's a weed whacker outside. Oh my gosh. Let me see if it's hitting my mic. It's definitely hitting my mic. Yeah, it sure is. Sorry guys. Hopefully they move along soon. All right. Where was I? Dude, that weed whacker's got to go. All right, so one of the functions implemented by the dash splitter library is the split arity1. This function aims to separate a string received via a parameter into a certain number of parts. The character used as a separator in split arity1 is always a dash, so a string dash. And the number of parts of the string is split into the defined globally by the application environment. This value is retrieved by the split arity1 function by calling application.fetch environment arity2 as shown next. All right, so we have our dash splitter module and our split that takes a string, and as long as that string is binary, okay, so it's fetching our parts environment variable here, all right, and so that's 3. And so when we're splitting a string, it's going to automatically, so due to this parameterized value used by dash splitter library, all applications dependent on it can only use the split arity1 function with identical behavior about the number of parts generated by the string separation. Currently, this value is equal to 3, as we can see in the examples below. So we're splitting this Lucas Francisco veggie into three different values in a list, right? So that works well. But then when we split something that is longer, it is splitting the first 2, and then the last 2 dashes is combined into the third value. So obviously, you can see an issue here, right? Because you'd probably want to have the control of splitting strings however you see fit, from different modules, maybe different parts of your application using it, and setting it here is very limiting because it's just a global variable that is not, you can't even override it. So refactoring, to remove this anti-pattern, this type of configuration should be performed using a parameter passed to the function. The code shown below performs the refactoring of the split arity1 function by accepting keyword lists as the new optional parameter. With this new parameter, it is possible to modify the default behavior of the function at the time of its call, allowing multiple different ways of using split arity2 within the same application. So now it takes the string and the options, right? And if parts has a, let's see, so a default config here. Okay, so this is in the library dash splitter, and by default, if parts is not there, it's going to be 2. All right, and then it splits it at the dashes into that many parts. So now when we're using this, we can pass in as an option parts 5, and it splits it into 5 different values for our list. And then if we don't pass in any options, it defaults to the parts being 2. All right. So of course, not all uses of the application environment by libraries are incorrect. One example is using configuration to replace a component or dependency of a library. I paused weird. One example is using configuration to replace a component or dependency of a library by another that must behave the exact same. Consider a library that needs to parse CSV files. The library author may pick one package to use as a default parser, but allow its users to swap to different implementations via the application environment. At the end of the day, choosing a different CSV parser should not change the outcome, and library authors can even enforce this by defining behaviors with the exact semantics they expect. Yeah, so I feel like you see this a lot with like JSON and I can't remember the other one, but the JSON parsers. Let's look. Poison, right? Yeah, that's what I was thinking of. So you can change what parser you're using right at a config level, and a lot of libraries allow you to use whatever you want, like HTTP requests as well. It makes sense. All right. Additional remarks, supervision trees. In practice, libraries may require additional configuration beyond keyword lists. For example, if a library needs to start a supervision tree, how can the user of said library customize its supervision tree? Given the supervision tree itself is global, as it belongs to the library, library authors may be tempted to use the application configuration once more. One solution is for the library to provide its own child specification. Instead of starting the supervision tree itself, this configuration options during initialization. This allows the user to start all necessary processes under its own supervision tree, potentially passing custom configuration options during initialization. Okay, you can see this pattern in practice in projects like NX and DNS cluster. These libraries require that you list processes under your own supervision tree. You'll probably notice this a lot. You add children to your supervision tree, and that is like sometimes it'll be your application.ex file, right? But you can also create your own supervisors, so you could include them there as well. So in such cases, if the users of DNS cluster need to configure DNS cluster per environment, they can be the ones reading from the application environment without the library forcing them to. Yeah, so then you can pass in your options here. It makes sense. You see this a lot whenever you're using libraries and you got to add children to your supervision tree. This is what's happening. All right, so some libraries such as Ecto allow you to pass your application name as an option called the OTP app or similar, and then automatically read the environment from your application. While this addresses the issue with the application environment being global, as they read from individual applications, it comes at the cost of some indirection. Compared to the example above where users explicitly read their application environment from their own code whenever desired. All right, additional remarks. Compile time configuration. A similar discussion entails compile time configuration. What if a library author requires some configuration to be provided at compilation time? Once again, instead of forcing users of your library to provide compile time configuration, you may want to allow users of the library to generate the code themselves. That's the approach taken by libraries such as Ecto. So when you go into your repo.ex file, or it might be .exs, I can't remember right now, you're passing in, so you're using the ecto.repo, and then you're passing in your adapter. So like I use Postgres in most of my projects, that is what you're adjusting there. Instead of forcing developers to share a single repository, Ecto allows its users to define as many repositories as they want. Yes. Given the adapter configuration is required at compile time, it is a required value on use Ecto repo. If developers want to configure the adapter per environment, then it is their choice. Yeah. So it just gives you a little more flexibility and makes a library a little more adjustable and usable by other scenarios. Or, you know, it allows people to use your library in a more flexible manner. On the other hand, code generation comes with its own anti-patterns and must be considered carefully. That's to say, That's to say, while using the application environment for libraries is discouraged, especially compile time configuration, in some cases they may be the best option. For example, consider a library needs to parse CSV or JSON files to generate code based on data files. In such cases, it is best to provide reasonable defaults and make them customizable via the application environment, instead of asking each user of your library to generate the exact same code. All right. Additional remarks, mixed tasks. For mixed tasks and related tools, it may be necessary to provide per project configuration. For example, imagine you have a linter project, which supports setting up the output file and the verbosity level. The verbosity level. Verbosity, I don't know. You may choose to configure it through application environment. So you could set up a linter library that you're using in your application environment, where you set the output files path and the verbosity. We'll say verbosity. And then, however, mix allows tasks to read per project configuration via mix.project.config. In this case, you can configure the linter directly in the mix.exs file. So you can set up and have your initialization options right here in your project options, which is pretty cool. So you could set up your linter and then set the output file and the verbosity right there. So additionally, if a mix task is available, you can also accept these options as a command line argument. So you could also do mix linter and then set your options output file path and the verbosity 3. Pretty cool. And now Jax is taking a drink, if you can hear that. But all right, that was awesome, guys. So design-related anti-patterns, some good stuff here. I think it's just kind of good to read these things and understand what anti-patterns actually are, just in case you're accidentally doing them. It makes you a better developer, right? So let's see. Next Tuesday, we are going to continue with this, and we'll be doing process-related anti-patterns. So that'll be awesome. And then next Thursday, we're wrapping up this series with the meta-programming anti-patterns. So thank you, guys. I appreciate everyone joining, and the chat never works, but thank you so much for hanging out. This was a lot of fun, and don't write functions that return different types based on the options sent in. All right, thanks a lot, guys. Have a good one. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. Later, guys.